5, Section 5, apply the remainder and factor theorems. All right, if you know one zero of a polynomial function, how can you determine another zero? So the first thing I kind of want to do is review, are you ready? Dun dun dun, long division. You're going to have to apply that skill today, except in a little bit more complicated way than just this. But if I refresh your memory this way, it'll help later. So remember, you have to do this. You have to kind of know how to do it by hand. I know you could whip it on the calculator. But remember what you do is you cover up these two and you say, does 6 go into 2? No. 6 goes into 23 3 times. And that's 18. 3 times 6 is 18. And I got to take 18 away from there. 23 take away 18 is 5. And then I bring down the 6. And I say, okay, how many times is 6 going to 56? And it's 9 times. So that means 9 times 6 is 54. So I'm going to take 54 away from there. And I have a remainder of 2. There's nothing left here. Let's just leave this as a remainder. So I would write my answer as 39 and my remainder over what I was dividing by. That's how you write your answer, and that's how we're going to apply that to polynomial division in a little bit. So, long division, polynomial long division is a method used to divide polynomials similar to the ways you divide numbers. Eventually it helps you get the factors. Synthetic division is another way, a method used to divide polynomials by a divisor of the form x minus k, and we'll look at that in a little bit. So, I know you kind of probably don't do the warm-up, some of you, but it really is a good idea just to refresh your memory and get you ready for what we're going to do in this lesson. So take just a second to do it. Okay, here you go. Here's the answers, Pythagorean theorem. Hopefully you remember it. Didn't have to look it up. This is what you would get, you should get if you did it right. Synthetic substitution, and you should find out that f of 2, when you plug 2 into the function, you get negative 4 out. And here you just had to stick the value of x, which was 200, into the function, and you'd come out with 765,800. All right, are you ready? Let's do a little bit of polynomial division. Oh no! Run, run, while you can! Run! No, I'm just kidding. It's not that bad. All right, so what we have here is we have this function, and we're going to divide it by this binomial. And yeah, you have to set it up just like something like that. So what I would do is I would write this nice long little thingy there. I forget what they're called, and you write your polynomial underneath there. And you're dividing it by x plus 3, so you write that outside. All right. So what you've got to do is, this is kind of a little bit different, but it's not too bad. You're going to cover up the rest of this, and you're going to look at the first term here as well. You're going to say, what do I have to multiply this first term by so that when I subtract it from this, it'll go away. So I need this term to be the same as this, actually, 3x cubed. So I got to multiply x by 3x squared. And I'm going to write that above my x squared term. Just stay with me here for a second. All right, now what I do is I multiply 3x squared times x, and that goes right here. That's 3x cubed. Also, I have to multiply 3x squared times 3, 9x squared. So sit and absorb that for a minute. Again, what I did was I looked at the first term here and the first term here, and I said, what do I have to multiply this by to get it to be that? And I decided it was 3x squared, and then I take that and I multiply it by the x and write it right here, and then I take that and multiply it by the 3 and write it right here, and I'm going to subtract this whole thing from what's above it. So 3x cubed, take away 3x cubed, that cancels out, which is my goal. Then I have 17x squared, take away 9x squared, and I'm left with 8x squared. So there's the first step. Then what we're going to do is I'm going to bring down the next term in the polynomial, which is 21x. Okay, again, I'm going to cover this up, and I'm going to look the first term here, and I need to know what do I multiply x by to get 8x squared, and I multiply it by 8x. So I'm going to do that. I'm going to write above my x term, I'm going to say plus 8x, and then I take the 8x and I multiply it by both of the terms in here. So 8x times x is 8x squared. 8x times 3 is 24x. Put parentheses around there, and you're subtracting that whole thing from what's above it. And your goal is always to cancel that first term out. And you have 21x, take away 24x, you have negative 3x. Bring down the minus 11. And you're almost done. Again, you're going to cover that up, and you're going to say, what do I got to multiply x by to equal negative 3x? So I got to multiply it by a minus 3. So now I'm going to take care of that. I'm going to go negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. I am subtracting that whole thing from what's above it. So I have negative 3 minus a negative 3x. Actually becomes plus, and they cancel out. And I have negative 11 minus a negative 9, so this becomes a plus plus, and it's negative 2. I have nothing else to bring down, so this is going to be my remainder, which will become part of my answer. So now what do I do is I take this and write it down here. It's 3x squared plus 8x minus 3. That's the quotient. That's the answer. But then I also have to include the remainder as negative 2 over x plus 3. And that is the exact quotient right there. So pretty cool, isn't it? Now, see, it's kind of the same thing as up here. We found out our answer was 39. We had a remainder of 2, so we wrote 39 and 2/6. Same thing here. We have our trinomial here and a remainder of this. You have to include that amount as well. Let's try another one. Okay, when you do this, you always have to, first of all, and I didn't do that with this one, but notice that you have all the terms in decreasing order, 3, 2, 1, and no exponent. Okay, the same thing here. I have to check. I have 4, 3. I am missing the squared term. So I need to include a 0x squared, and then I have 1, and then the constant. So we're taking this and we're dividing this. Exact same process. Let's set it up the same way. 2x to the 4th plus x cubed plus, I have to include this term, 0x squared plus x minus 1. And I am dividing it by x squared minus 2x plus 1. Okay, look at your first term again. I have x squared here and 2x to the 4th here. I need this to be the same as that, so I'm going to multiply by 2x squared and place it above the x squared term here, 2x squared. Then I take that and I multiply by every term in here. 2x squared times x squared is going to give me 2x to the 4th. 2x squared times a negative 2x is going to give me minus 4x cubed. 2x squared times 1 is going to give me plus 2x squared. And I'm going to subtract that whole thing from what's above it. These cancel out, which is my goal. And then I have x cubed minus a negative 4x cubed, which becomes a plus. So I have 5x cubed. And then I have 2x squared times 1, which is plus 2x squared. Oh wait, I already did that. I'm sorry. 0x squared plus 2x squared I add down here. Okay, so I took care of that. Now I got to bring down the x. All right, now let's look and see again. My first term here, I need x squared to become, what do I multiply x squared by to get 5x cubed? I would multiply it by 5x squared. excuse me, 5x, multiplied by 5x. So 5x times x squared gives me 5x cubed. 5x times a negative 2x gives me minus 10x squared. 5x times 1 gives me 5x. I'm going to subtract that whole thing from what's above it. These cancel out. 2x squared minus a negative 10x squared gives me positive 12x squared. X minus 5x gives me this. And I'm almost done. Bring down the negative 1. Minus 1. Okay, so maybe some of you caught it. I made a slight mistake here. Right here I have 0x squared, take away 2x squared. This becomes a minus 2x squared. That would make negative 2x squared, take away a negative 10x squared. That would make this a plus. Consequently, I would have 8x squared here. Sorry about that. Okay, so the last thing for this problem is I have to say, what do I multiply x squared by to get 8x squared? I'm going to multiply it by 8. So I'm going to write plus 8 up there. 8 times x squared is 8x squared. 8 times negative 2x is minus 16x. 8 times 1 is 1. All of that is going to be subtracted from what's above it. That goes away. Negative 4x minus a negative 16x becomes 12x. And then negative 1 minus, oh, this is 8. I'm sorry, man. I need to go home. It's Friday night. This becomes minus 9. I can't go anywhere with this. This is my remainder. All right, so I'm going to write out my answer. Right here is the quotient, or part of it, 2x squared plus 5x plus 8 plus a remainder of 12x minus 9 divided by what I have here, what I was dividing by, x squared minus 2x plus 1. This is probably one of the most challenging types of problems that you'll get with long polynomial division. There's an easier way. I know you'll like that. Divide using synthetic division, set up the same as synthetic substitution, and what is left underneath are the coefficients of your answer with the last number being the remainder. So that's where it's slightly different than synthetic substitution. Now in the front, I said here it's a method used to divide polynomials by the divisor of the form x minus k. Here we have a polynomial and we need to divide it by x minus 3. So if I think of this as x minus k, that means I'm actually, 3 is going to be the positive. So I'm going to set it up like this, just like synthetic substitution. Put my 3 out there, write the coefficients, but first I'm going to check I have 3, 2, 1. I'm good. I don't need to stick any zeros in there. So I'm going to write 2, 9, 14, and 5. And it's the same process as you did before. You bring down the 2. 3 times 2 is 6. Add those together, you get 15. 3 times 15 is 45. Add those together. I know it's getting to be big numbers, but that's okay. 3 times 59 is 177, and you add those together. Now, since we have a number here that is not 0, this is the remainder in our polynomial division. And what you have here are the coefficients of the answer. So you have 2x squared plus 15x plus 59 with a remainder of 182 over what you were dividing by, x minus 3. Way easier. Let's do another one. Okay, so again, if I remember that this is x minus k, if I were to get this in this format, that means I would be using a negative 3, so I've got to use negative 3. So I'm going to set it up. I'm also going to check here I have 3, 2, 1. I don't have to fill in with my synthetic division any zeros because I have decreasing exponents. So I'm going to put negative 3 out here. This has a coefficient of 1, coefficient of 4, negative 1, negative 1. And I'm going to do the Synthetic division here, bring down the 1. Negative 3 times 1 is negative 3. Add 1. Negative 3 times 1 is negative 3. Add those together, it's negative 4. And negative 3 times negative 4 is 12. And I have 11. This is my remainder. This is the trinomial that will be my answer. So, coefficient of 1, so it's just x squared. Another coefficient of 1 is just x minus 4 plus 11 over x plus 3. There we go. Beautiful, isn't it? Hold on just a second. Let's try and get a little brighter. I don't know why it goes dark sometimes. All right. So you're going to be using a lot of that synthetic division. Here it says factor completely using the given polynomial as a factor. It just means that when you get an answer, make sure the polynomials left can't be factored any further. So we're going to set it up the same way. Remember, this is x minus k, so we're actually going to use just 3. So I'm going to set it up. I have 3, 2, 1. I don't need to fill in any zeros, so that's a good thing. Okay, so let's write down the coefficients. 2, negative 11, 3, and 36. Bring down the 2. 3 times 2 is 6. It's negative 5. Negative 15 is negative 12. Negative 36 is 0. Oh, this is beautiful. This means there is no remainder. Okay? So, we have to remember that given polynomial as a factor, this is a factor. They already gave us one factor. So that's going to be part of my answer. The rest of my answer is going to involve what I have here. So it's 2x squared minus 5x minus 12. And there's no remainder, so I don't need any of those funky fractions like that. Okay, now what I need to do is make sure I can't factor this any further. And I believe I can. X minus 3 is still going to be part of my answer. Okay, anytime I have a trinomial where the leading coefficient is not 1, I just automatically set up the box. Hopefully most of you know how to do this. You can do it your own method if you don't. Okay, I got to fill these boxes in. I do that by doing 2 times negative 12, which is negative 24, and I got to figure out factors of negative 24 that add to negative 5. And it turns out that is negative 8 and 3. So I'm going to put negative 8x and 3x. Doesn't matter what boxes you put those in. Factor out. I'm going to do this fairly quickly. You can check it out slower if you need to. That's the beauty of video. And here I have 2 more factors, x minus 4 and 2x minus 3. Now it's factored completely. All right, let's do one more as practice. Remember, this is x minus k, so I'm going to use 4. I'm going to check that I have all the exponents, 3, 2, 1. Yes, I don't need to fill in any zeros. So I'm going to say, okay, I'm going to use the 4 outside there, 1, negative 6, 5, and 12. Do the synthetic division. Oh, beauteous. A remainder of 0, so I don't have any funky fractions in my answer. What I do have is the factor that they gave me, and then I have this trinomial right here, x squared minus 2x minus 3. Since this leading coefficient is not 1, it should be pretty easy to factor if it is factorable. So again, I look at the last term, factors of negative 3 that add to negative 2. And that would be negative 3 and positive 1. So those are going to be my 2 more factors. Voila! I've come up with all the factors. Okay, one more thing you're going to have to practice in this whole division thing and finding factors and so on is they're going to give you a polynomial function. They're going to give you one of the zeros, which is, you know, where the polynomial hits the x-axis, and they want you to find another 0. So basically what they're doing is they're giving you what you're going to divide by in synthetic division. So you just stick that outside the bracket, fill in the polynomial. I have 3, 2, 1, so I don't need to include any zeros. Just write down the coefficients. and start the division. Look at that. No remainder, so that makes it easy. Okay, now, since they told me one of the zeros is 4, that automatically, hopefully, makes me realize that it's x minus 4 is the factor that that came from. Because when you add 4 to both sides, it'll give you x equals 4, which is one of your zeros. So you're going to include this factor when you write it down. And you have this trinomial, x squared plus 5x plus 4. Your goal is to find the other zeros, so you got to factor this trinomial. Again, the leading coefficient is just 1, so it's real easy just to look at this last term and say, what factors are 4? Add to 5. It'd be 4 and 1. So I'm going to write the trinomial as two binomials of x plus 4 and x plus 1. Set the whole thing into equal to 0, which is how you find the zeros. You already know this is one of the zeros, 4. And then you got to set x plus 4 equal to 0 and find out that another 0 is negative 4 and another 0 is negative 1. So they only asked me for one other 0, but I found both of them. So there you go. Wasn't that cool? A lot of work, but not too bad if you take your time. Don't run too far.